Awesome. Thanks, Pep. Let's have a round of applause for Pep and crew. This is like such an awesome event. Normally that's just complete pandering, but but in this case it's completely true. This is like, I can't believe how beautiful it is here, and I want to thank you guys actually for being in this room right now, because it is so insanely beautiful out there that actually I'm a little almost disappointed that you're here right now, given how awesome it is out there. This is actually is almost like a follow-up to Tone's talk, if you were in their talk before. And I'm going to actually kind of like take you from where he left off when he was talking about optimization and automation. And he started talking a little bit about multi-arm bandits and some other machine learning techniques. And so while you may think, hey, I'm kind of a small company right now, this isn't really for me, I think this is really where the future is going to be. You don't know where you're going to be in the next few years, and a lot of you are agencies, and you might start landing some really big clients, which after this I expect that you will. And so it'll put you in a good position to at least have some sort of framework for understanding these problems. It won't make you an expert, but it'll help you evaluate and think about these problems longer term. So with A/B, one of the issues, at least that I have, and Craig and whatnot can argue with me later on tonight, is that I happen not to really like the idea of thinking about optimization through the A/B testing lens, and that's because it really focuses us on the idea of picking a winner. And there's a implicit almost risk adversity, right? Because we're afraid of picking losers. And I think really when we want to think about optimization, what we're thinking about is using data to help assign customers to experiences. And it may very well be that all of our customers are going to get the same experience in sort of the A/B testing case. But if you really think about it sort of at scale, the idea is that different types of users really might respond better to different types of experiences. And so that's kind of the overarching idea, is that we're going to use data, and data's value is really only in helping us optimally assign customers to experiences. So I'm going to first, it's going to be super basic, and we're going to talk about decision rules, and you're going to be thinking to yourself, total waste of time, because it's totally obvious. But it's going to help us as we get into the more hairy stuff a little later on in the talk. I'm going to talk about optimization as really a method for picking these rules. So it's going to be a slightly different approach to how we normally talk about optimization. I'm going to talk about experimentation, so both A/B testing and multi-arm bandits, and we're going to go through in some detail multi-arm bandit approach. Don't worry if you don't get it right away. I have a lot of resources in this deck, and you can use this later on as a working deck. I've got a lot of resources here. And then I almost dropped this targeting predictive analytics, but last night someone insisted that I included it, so you're going to miss out on 10 minutes of sunshine, because we're going to talk about that a little bit. Put that in there. So wait, first of all, is Noah here? That bastard. So he's like, he was at, we were at dinner, and he's like, I'm going to be in the front row for your talk. Multi-arm bandits is a joke. And I noticed that the two American guys, Brian, you here? No, totally calling you out. So the two other Americans used their images, like themselves as like the models. They were like the honeypot for their product. And I don't need an A/B test to know that my face is not going to work for that, but it will work as a warning, right? So this here is this is an eigenface. This is the first principal component of my eigenface here, and this is a method that's used in facial recognition. But also for all the SEO folks, this is also a very similar approach to what's done in SEO. And I had a blog post that someone was interviewing me, and I thought it would be a good idea to use this as my face. So total cautionary tale, don't be this guy. And so all of my resources I've ranked. And so the more of these faces, it's a warning that it's more technical. So take them with a little bit of caution. So data, I'm going to claim that there are really two main data types. At least as far as we're concerned in the automation optimization space. And I think this is actually really important to get clarity when people start talking about big data, and it gets confusing, and there's all this magic about predictive analytics and deep learning and whatnot. This will give you clarity on on how to collect data and sort of map the data together. So there's two data types. Number one is measure data. This is web analytics right here, and this is all about getting in personal and really collecting all the data you possibly can, right? All the good stuff, right? Personal data in there. So this is collection, but this is really a passive activity, and this is sort of your correlational data, right? And so this is the data that you might get in your web analytics package, or data that you're collecting about your users' behavior, but it's not data that you've manipulated. It's nothing that you've done to them. This is just how they respond to your process as it stands right now. So this is about them, and this is almost a way of describing your customer and points in times when they're interacting with you. We have another type of data, this sort of manipulation data, and this is where our causal information comes from. This is where we can start making statements about whether or not we're doing something is making a change in the world, and it's causal. So A induces some behavior, and B might induce some other behavior. And we might want to reward A and B differently. And so we need to have some sort of framework or process to link these two data together. So one is almost like our customer on the left-hand side. It's a way of defining the customer as a set of measured observations. And then on the right-hand side, these are the things that we can do, right? So there's the button or what have you. Or this also doesn't have to be presentation layer stuff, right? So it doesn't have to just be about the web. It's really any transactional activity. And so there was talks yesterday and earlier today about the email campaigns and the notion of a trigger. And this is very similar to that. And the event here could be some sort of time after a customer has visited, and then when do we send the email? So it doesn't have to just be a visual thing. It could be call center activity, IVR activity, really any transactional event that has a call to action to it. So decision rules, and quickly talk about them. This is going to be our way to link the two types of data together. Very simply, if this, so if we see something, then that, right? So you're definitely not getting your money's worth with this right now, but it's helpful to think about that as a logic that links observations to actions. And this is like your marketing program right here. And you can think of a decision rule as like a mini program, actually. And think about like those triggers in your email software or whatnot. And it's really just linking some sort of activity to some sort of action. Right? So if we see something, then we're going to do something. So in A/B tests, we can recast in this framework. So if anybody, so we don't segment, then we're going to do either A or B. If we're at Elite Camp, then we like one of these guys, or we want one of these guys not to bother us. Obviously, get rid of the weakling first. And actually, that's a good idea, actually, just thinking about optimization. We often think about the winner, but when we have a large set of possible options, a lot of times what we want to do is not play the bad one. Because sometimes the two top ones might be almost equivalent. So we don't really need to spend too much time worrying about whether one is better than the other, because they're going to give a very similar return, but we definitely want to filter out the bad eggs. But how are we going to go pick the rules? There's like a million possible. We're making all these decisions all the time, and most of the time you're not doing A/B testing, right? We live in the world. We make decisions in the world, just like your website is trying to make decisions, or your marketing application, and yet you're not running an A/B test. When we just visited Estonia, and I'm assuming for many of us it's the first time in Tallinn. Not everyone, but many people. You don't know what the good restaurants are or the good cafes. You're not going to run an A/B test to figure out what a good cafe. You're going to go to one, and if it's pretty good, you might return to it, and if not, you're going to keep searching around. So we need to have some sort of method to pick the rules. One is like domain expertise. That's part of the reason why you're here. And if I had a fashion company, I'd way rather have someone like Anna Wintour advising me on helping me make decisions than a bunch of data scientists, right? And if you don't know about Anna Wintour, you can go and watch a little video about her documentary. And also we learn from experiments. So it's really this almost cyborg approach, right? So it's the humans, and then the humans have some domain expertise, and then we want to optimize over that, right? So I would claim that optimization is really learning efficiently, right? Because we want to learn these rules as quickly as possible. Earlier today we heard about opportunity cost, and Tone talked about implicitly he was talking about the confusion matrix. And we want to learn that as quickly as possible, but we also want to apply the best rule. So, for example, applying the best rule that we know now is all of us should be outside right now, right? Because that would give us the most immediate satisfaction, I would imagine, rather than listening to this voice at the moment. But you're hoping that you might get something in the future by sitting in this darkened room as opposed to being out by the beach. And so that's this trade-off that's always behind all of our decision and learning. So one way to do this is what's known as the multi-arm bandit. And it's really actually quite simple. The idea is a bandit is just a slot machine for those of you who know slot machines, and they steal your money. This is actually more representative of a casino than, you usually think of Monte Carlo or Vegas, but no, you got like the bus over there, totally appropriate because all these folks are gonna trundle on the bus ride home. This woman over here, she's looking at a week of cat food because she's just wasted all her money. The dude is like, he's just wasted all of his rent money, totally depressing. And so really you go into the casino and the idea is to walk out of there with as much money as possible at the end of the night, which hopefully isn't negative, which most cases it probably is, right? And so you don't want to like spend time playing one of the games that is a poor performer. So you want to learn as quickly as possible. And so this is the idea of playing and optimizing at the same time. So incorporating opportunity cost to our experimentation. So which is better, right? And there was all this drama on the web between picking one or the other, which you obviously don't need to do. So like in Hacker News, there was this thing about multi-arm bandits, and then there was some guy who had an optimization toolkit that said no A/B testing is better. Damn you, Paras! He totally made all this drama happen. But really what it is these two things, these are two different approaches, and it really depends upon the use case. It's not just me telling you that this is a good idea. Google's experiment is based upon multi-arm bandits. So this is now in the mainstream, and so it's a good idea to have a good handle on it, whether or not you decide to use it or not, just to have a good basis. They use something called Thompson sampling. We can talk a little bit about that afterwards if you'd like, if you're interested in that. Adobe, I'm assuming their target, anything that's adaptive is really probably using a bandit. So Adobe has been using this for a long time, probably from their product Touch Clarity, which they bought around like 10 years ago. Acquia is interesting. They have a product that's embedded into their CMS. They're Drupal guys, but so you don't have to do any tagging or anything, and it's just you can roll experiments right from your CMS. And we do it too. I'll talk about a little use case that we do. So just a quick review, A/B test. Anyone comes in, and then we pick between A and B, right? Super simple. And then we evaluate it. We don't have to go this in too much detail, but we calculate the average value of A and B. Then we calculate some measure of variance or spread. We can think of that as sort of uncertainty in our estimates. And then we calculate some sort of test statistic. Usually it's a T. I think the Optimizely guys have switched to sequential walled. I'm not sure why, but you can use any test that you really want. And then you use this measure as some sort of measure of evidence. You can think of it as sort of signal to noise. On the top is our signal, and on the bottom is our noise. I wrote a blog post for PEP. If you want to learn more about sampling error and p-values, that's fairly accessible on PEP's blog. And then there's some more technical documentation. If you're interested in this, you can follow up. So as a rule, if anyone, once we learn it, then we're going to offer everyone B. So how does it work? Multi-arm bandit. So we're really trying to search in the most promising area. So we don't want to keep searching in options that we have evidence that are pretty poor. So if you remember confidence intervals, I'm hoping you do if you're running A/B testing, this is actually pretty important to have a good handle on. But basically, the confidence interval is we have a mean value. That's the estimated value that we've collected so far. So let's say it's 2.3% or whatever the conversion rate is. And then we calculate this measure of uncertainty. This is sort of the variance of that. So this is our you can think of it as sort of the expected range that our data is going to sit in. There's a good refresher video. So if you're not fully up to speed with this, you can take a look at that, and that'll be useful for you. And so Not all bandit methods take this approach, but this is a good way of just thinking about it conceptually. All that's happening is that we still take the mean value, just like you did in your A/B test, and you chop the confidence interval in half, right? And we're going to be optimistic. So we're going to give all of the options the benefit of the doubt conceptually. And so we're going to calculate a new score. So instead of selecting based upon the mean, or in A/B testing you randomly select, but instead of selecting the mean, which is what we would normally think of as our current best guess, we're going to add that upper part of the confidence interval, the uncertainty, right? So we have two measures that are going into our score. We've got the average value, what we've calculated, and then our measure of uncertainty. So our score is going to be higher when we have a higher value, which is normally what you would think of. So if A is doing better than B, you'd normally want to select that. Or if you have you have a lot of uncertainty in an option, right? And so the more uncertainty. And this is that implicit trade-off between learning, and we have uncertainty, and using what we know. So it works kind of like this. We use the upper portion of the confidence interval as the bonus, and then we just select the highest one. And if you're using a Bayesian approach, you're probabilistically selecting, but it's basically the same thing. And so here we have our three options. And A is the poorest performing currently, right? Has the lowest conversion rate. But it has the most uncertainty around it because we haven't played it as much as B or C. So we're gonna select A, right? And then we play A, and then we see what happens. We played A, did a little bit better, but by playing it, we've gotten more evidence about its estimate, about how good it is. And so we've dropped its uncertainty. So now C is the best one. And so you can see how the system is just going to iteratively keep going through this as we get in more information. These confidence bands start shrinking because we become more certain about our guess. So when would we use this? So this is where we can decide when we want to use A/B testing or bandit approach. Is it perishable? And I think this is a key thing to be thinking about your information or your test or just data in general. How long does it live for? So if I'm a publisher and I have news articles, or I'm doing headline tests, or even just article optimization for different types of people, the half-life on those things is like, what, 4 hours, 2 hours? So what are you going to do? You're going to run A/B tests on all of those things? The information that you learn is going to be completely perishable. And in a couple of days, it's going to be useless. So that's a case where you might want to use a bandit. Flash sales is another thing, or campaigns, or there's a holiday sale. Anything where there's a time component, think about it. But if, like a site redesign, that lives for a long time. And so it doesn't really matter if you're going to do a bandit test, because of the thing, you're going to keep it for like, several months. What difference does it make if it takes you a day or two longer or a week longer to get a more reliable estimate? So. Also, the complexity of the problem. So I would imagine that most folks have fairly simple use cases where we're just altering some sort of content or redesign. But when you start scaling this thing out, and let's say we're running 250 tests, or we have, trying to personalize it, right? So it's a much more complicated. That's a case where we might want to start thinking about automating it, and the bandits is the approach when you want to start automating your learning. But if you have just a few options, a few tests, you're only doing simple targeting or none at all, there's no real reason to use the bandit. Also, if you have something like a top K of M, so you're a publisher and you want to, or you're a product e-commerce site, and you have, let's say, there's 20 products that you might want to show to your client, but you want to show just the top 3. Let's say, what's the top 3 products? So it's not like an A out of K option, like in a normal A/B test where you're picking one. Here you might want to pick, like, say, the top 3 or the top 5. And this is another use case where a bandit is going to be useful for you. Because if you think about it, all the possible combinations of those 20 is like this huge space. And so you'd have a really hard time using an A/B testing methodology around that. So here's a use case. This was actually from 2010. We followed process originally. We didn't do lean startup either. We did definitely fat, obese startup. And so we had like super complicated system that really was only suitable for the largest clients. So Pfizer, one of their first tests with us was they had bought a couple of other pharmaceuticals, and they had content that they wanted to present to the right type of user as they came in, right? So one of the main search queries that were coming in were based upon Wyeth, and that was a pharmaceutical that Pfizer had purchased. And so they had a search segment on that. They had bought King Pharma, and then they had everyone else. So there was 3 segments. The problem is there's targeted. And then they had sort of a multivariate test they wanted to run. They wanted to select the best topic, the best type of content, list of content for each segment. But then they also were running this other navigation UI thing, and they wanted to make sure that that was incorporated in the test and not biasing anything. And they also wanted to test the bandit approach. Now, just to be clear, it's pretty obvious that the Wyeth searchers were going to want to see Wyeth-related content. And that's the reason why we ran this test in the first case, is they just wanted to see if the machine learning would be able to figure out what we already knew. And this is actually a good thing to think about. When you're starting in the testing program, or you're starting with bandits, it might make sense to do something that you kind of already know the answer to. And then you want to see if the system is able to figure out what you already know. You can also do that with artificial data, but this is a good test, because if it comes back with a result that is not consistent, then you might want to think about whether or not it's actually finding the signal. So they had 2 sections on the site. There's this main block where they wanted to figure out what the best topics should be. So there's a list of content, and then they had this right nav here. And so here are the 3 different types of content listings. You can think of this almost like a product assignment or topics for content. And then the navigations. And so we set up a test, an agent, a multivariate agent, and we set it to be adaptive rather than random. And then we created a few of the segments, and that's based upon search terms. So you know this is old, because this is still when Google was giving us search terms, and now you probably couldn't do this unless you just had Bing users, I guess. And so we saw from the results, I don't know if I can laser pointer the thing. So the top result was all of the Wyeth-related content, right? So we have the topic, which is Wyeth, King content, popular content. And this is for just the Wyeth segment. So we can just look at one segment. That all rose to the top, right? And so we saw conversion rates of almost 8 or 9, 10%. And the system selected this content most frequently. So over 70% of the time, the bandit selected the Wyeth-related content. And we see the navigation really didn't make too much difference. Probably the tab had the greatest efficacy, but in terms of the main effect, really the topic, which is what would make sense. So how would this be different than if we did an A/B test? So remember I said before with the bandit, you're really sort of searching over the most valuable. You want to spend most of your time on the area that you think is most valuable. So here we have, this is the result from the bandit, right? And so it's a similar result, but the confidence interval, these are the confidence intervals, is really small. So we have a lot of certainty around our result. And when we ran the A/B test, we had a much greater variance, right? Because we spent more time during the bandit on the higher value option. But here, on a low value, on the default, which was a very poor performing, we spent much less time on this option during the bandit. But during an A/B test, we would have spent more time on it, right? And so during the A/B test, we have more confidence, but we don't really care in this case. We just really wanted to pick the best one. So this is wasted resources. We spent all this time getting more and more certainty on a result, but this is a weakling, right? And so the bandit sort of automatically will start discharging the weaklings. So as a summary for the multi-arm bandit, you want to use it when you might want to do automation. You have a changing world, so maybe the problem is you have different events are happening, and they're affecting the flow of how users are coming to your site, and you want the system to be constantly learning, and you have a very complex type of problem, and you want to do it at scale. But is that going to be enough, right? If we're just doing, this was just segments, these were fixed segments. And is that going to be useful for us at scale? Well, the problem is that segmentation, as we normally think about it, really doesn't scale particularly well. So let's say we had 35 observations about our user, right? Maybe they're Facebook, high spend, come in from an urban area, whatever. That's billions and billions of possible combinations. There's no way you could possibly segment this out and learn anything, because most of the segments that you constructed would have would have no data points, right? So we're going to have to do something else. We can't just have these mutually exclusive segments. So what are we going to do? This is where predictive analytics comes in, right? And so we're going to learn a model, right? And we're going to learn some sort of mapping between our customer and our experiences. Not enumerating all the possible combinations of our segments, but we're going to learn a more compact representation. And that's really what the predictive modeling is about. Here are some methods. It doesn't really matter too much which ones you're using, but if you want to study up on this and you want to become familiar, there's regression, there's deep learning methods, logistic, forest, those are tree-based approach. We have some pretty good, I would say very good resources about this that if you want to learn up on this, they're pointers to the experts in the field on each one of these topics. But as I said before, don't really sweat the difference. So if someone comes in and say we're using XYZ machine learning algorithm versus some other machine learning algorithm, that's like a second order effect. That's not really going to be what's going to make the difference, right? That's not that important which one. So here's another case study, which is a sort of a more complex problem. We have a client which is a governmental lottery, right? So they have huge traffic and they do tons of sales on it, as one might expect. And they were wondering, hey, what if our minimum suggested offer or minimum suggested number of lottery tickets was $2 versus $10, right? Would we get more money if we started offering up the suggested bid being $10 rather than just $2, right? And you could see there being two effects here. One might be you'd have lower conversion rate with a $10 offer, but you have higher profits, right? You have more revenue coming in. And they had a lot of customer data. And so what they wanted to do is say, well, it may very well be that certain types of users are going to respond better to the $2 offer. It's going to be more valuable to them. And other types of users, it's going to be the $10 offer. So this is like this is like the classic predictive analytics looped in with experimentation. So we've got both things going on here at the same time. We've got to learn some sort of model. So we've got to predict for all of this customer data which one of these experiences is the best. But the only way to do that is to sort of run experiments over these two experiments because we don't have information on the $10 beforehand. So we've got to like kind of So the idea is to blend predictive analytics with experimentation. And so our system is set up to do this, and so what we did is we learned all of these rules conceptually, right? Because that's really what predictive analytics is doing, is we're trying to learn a rule, right? If we have a certain type of audience, then what's the best option for them? And so we saw that for these types of audiences, and I had to black some of them out because it would have sort of been a little giveaway about who the client was. But let's say a user comes in on, I guess, Friday, and they're during a particular time of day, and they're not logged in. We predict that they're most likely to be 10 is going to be the most valuable for them. But maybe there's another user over here who is of a certain age and is on a different day, different gender. Then 2 is best, right? And this is not something you can do with an A/B test, right? Because you have all of these data points, and you could either run this as like a big segmented A/B test, but you'll never have enough data to do it. And what predictive analytics is doing, or what machine learning is doing, is it's sort of helping you generalize and learn over all of these use cases. So they're able to sort of share their learning across in a way that's efficient. And so we can also know what the predicted value is for each audience. You can say, well, it's going to be around $4.90 if we play the $10 bid, and it's only going to be $4.62, right? And then the bandit algorithm can select based upon these measures, right? And that's really kind of how it works. It's this iterative loop where we're passing in information about the user, and then we're learning a model, and then we're making selections, and then as we begin to learn and we have greater confidence on our results, we start applying that more often. So we're still going to experiment. For this type of user, we're still going to pick 2 some of the times, but we're gonna play 10 more often so we can get the advantages of that result. So to summarize, optimization in just 5 parts. You need measurable goals, right? So you have to have some sort of call to action, some sort of, Simo was just talking to me before this, and this is a key bit, which is what are your goals? You need to have actually goals that make sense for your organization. You need to be able to observe the environment. This is the data collection part. You need to be able to do something, and then you need to observe the outcomes from your actions, right? So normally this guy on the left is gonna get the bone, this guy isn't, although I'm a bad disciplinarian, and so I'd probably give that guy a bone anyway, cute. And then for bandit, we wanna spend more time on what we think is the best option, but we're still gonna try out the poorer performing option in case we actually find out that that actually might be the best one long term. So at the end of the day, we're gonna learn if we observe an environment, we're gonna take some sort of action, and then we're gonna see some sort of goal, and that's it. It's as simple as that.
We have a few questions here, and we're gonna pass the mic back and forth. So, I may have missed it, but which implementation tool do you use for bandit testing?
Well, we use our own software. So our Conductrix has various multi-arm bandit algorithms embedded into it. But there was that list before. You could use, if you wanted to, Google has their tool, Adobe's Target, I think, has that in it. And I imagine you'll start seeing most of the tools are going to probably have to start providing that type of capability. But you can write your own if you want.
How much traffic per month does a site need to use predictive models?
Yeah, that's going to really depend upon the nature of the problem. But I'll refer to Tone's, that was a pretty good, I think, summary. I think he said around 10,000 conversions per month. That probably makes the most sense. But, I mean, if you think about it, if you're just doing A/B testing, you're doing prediction, right? You're making a prediction about the efficacy or the result of each one of the options. And all predictive targeting is we're saying, well, if I know something about the user, then what's the average going to be, right? So if you have a very small problem where you're not looking at a lot of data features, you need less information. So it scales to sort of the complexity of the problem that you're looking at.
How does the tool come up with these predictions? Would age or time of day really be a differentiating factor for which experience is best suited for the user?
So that's going to depend upon the use case. So what it does is the system is aware of what attributes of the user are at the time, and then it looks and it waits and sees if the user converts or not. And then if the user converts, it sort of pays back the attributes that were active at that time. And so it can learn and see whether or not it makes a difference. If someone is, so for example, we had a use case with an e-commerce company in the UK, and they were selling product, and they found that people who were coming in from Europe, on average, were better customers. It didn't really matter whether it was product 1 or product 2 or product 3. In average, they always spent more, right? So that's one aspect of predictive analytics, which is trying to figure out, what the average value is of that user. But that's not really what we care about here. What we care about here is deciding between competing options. And so it also happened to be that the European customer preferred one product over the other, right? So for that type of customer, we wanted to present, the European style product. But it also happened to be that the lower value customers preferred something else. So really the system was sort of cleaving users into sort of winnows and whales, right? And so minnows and whales. So the minnows liked one product and the whales liked another product. The higher value customers preferred a different type of product. So yeah, the system, that's exactly what the analytics system is designed to do.
How do you do predictive analytics if your traffic quality and traffic sources are constantly changing, fluctuating?
Yeah, that's a great question. So I'm not sure. So really with any of this, you can't do A/B testing either, right? So if you have some sort of structure to your data that you're not capturing, if you take any given slice of that structure and it's not similar to what's going to happen in the future, then really any of your analytics is not going to be generalizable in the future. So if what you're saying is that there's really no structure to your data and your users are always constantly changing, it's almost like a random pull all the time, then analytics in general will never help. So my guess is that that's not really, you're at that most extreme point. And so that's another advantage of using the bandit, where it's always continuously sampling. So it's designed, if the change is slow enough, it can pick up on the change and start reweighting the options based upon that. But yeah, if your data is constantly changing, then it's actually useless. There's no information in it.
And last question, how does max number of possible outcomes correlate with data volume?
Yeah, that's another good question. I'm not sure whether or not there's a fixed factor. It's probably like some square root or log of the number of features that are coming in, or the cardinality of the problem, right? So if you have, let's say 10,000 different options that you're trying to select from, this probably isn't going to work if you don't have some sort of way of saying that of having topics for each of the options, right? So if they're not similar in any way, you can't learn over them, then you'll have a really hard time using an bandit approach. And that's kind of what the recommendation systems are like. So Netflix, that type of problem where they have a ton of data and they have a ton of options, they'll use a different type of methodology. In fact, they'll use that eigenface stuff that I showed you, they'll use a methodology which is similar to that. So they'll use this type of methodology for trying to figure it out. But that means they already have the data, and also that means they run into a problem, which is what all recommendation systems run into, is that it's built on data that wasn't using the recommendation system. And now you have some recommendation system, and you're using that to select product for users, but now you've actually changed the structure of the data. And so you don't really know whether or not the recommendation system is the thing that's actually providing the value.
Well, thank you, Matt.